Assalamu alaikum warahmatullahi wabarakatuh, everyone, and good day. I am Abdul Hamid Buraika, and I represent the CEO of the Micho Holding Company. We have a group of engineers came to present us their project, which will be related to our product, the Spark Plug Toolkit. First of all, I'm glad to be here in this meeting and I would like to allow you to show us your new project and what you have to offer us. First of all, Assalamu alaikum wa rahmatullahi wa barakatuh, Mr. Khairul. Please explain to us what you have.
Waalaikumsalam, Mr. Hamid, the CEO of Meki Holdings Sindirian Berhad. Nice to meet you. I am represent behalf of my team. We are very grateful to have a chance to have an cooperation with your company. Our project is to make a modification and improvement to a spark plug socket LC135. So let me show you. Let me show you the project, the spark plug socket. So the problem about the spark plug socket is the thin wall of hexagonal shape is a bit distorted and causing it not to fit with the spark plug. So it will give a difficulty to use it. Then the socket itself is not perfectly aligned between the top and the bottom due to the torsion for long-term usage. Based on theoretical and as also assumption about the calculation, we have average shear stress which is 37.5 megapascal, and for the angle of twist we have a 7.678 times by 8 power of negative 4 radian. So we want to decrease shear stress and also the angle of twist because we want to prevent failure and minimize the deformation occur in material. So we will talk about the improvement later. I think it's all from me.
Thank you, Mr. Khairul, for the clear explanation. I totally agree with you. Many users face this problem, and theoretically, this might be an effective solution. Guys, can you tell me about more about your modification, please?
Thanks to Khairul for mentioning the two major problems we found in our socket. Now I will add on two more minor problems we also found from the socket and the modification to solve this problem. Okay, from the old socket, the old product, we have found a few problems. They are, of course, the first two major problems mentioned by Khairul Nasran. The socket itself is not perfectly aligned between top and bottom due to the torsion for long-term usage. And the second is the thin wall of hexagonal shape is a bit distorted and causing it to not fit with the spark plug LC135, our model. And the two minor problems we found also is that there are a lot of them throughout the whole socket. And the last one is when dismounting and installing the spark plug, the socket always slip or lose its grips with the spark plug. For solving the two major problems, some modification will be made where we will decrease the length and increase the wall thickness of the socket. So next we can see at the formula, we want the shear stress to be as low as possible so that the hexagonal shape of the socket can be remained even under heavy usage. So from the formula we see that if we increase the thickness of the wall, the shear stress will be low. So this is what we want. And next, we also want the angle of twist to be small as well, so it can still work or not distorted easily. So we see that if we increase or decrease the length, it will directly cause the angle of twist to change. So we want the angle of twist to be small so we can decrease the length. So we can see the relationship from the formula here. We also recommend to change the material used to manufacture the tools from chromium vanadium to chromium molybdenum. as chromium molybdenum has a higher Young modulus than the original steel chrome vanadium, where we can see that the Young modulus of chromium molybdenum is higher, which is 250 gigapascal compared to 200 gigapascal for chromium vanadium. It can help us to decrease the angle of twist, where we can see the formula. If we increase the G, the angle of twist will decrease. This is what we want. And not only that, chromium molybdenum is characterized by excellent impact resistance, strength and hardness, which can help us to solve the dent problem on the socket itself.
Okay, that's clear. Thank you, Mr. Kang. So now I would like to hear from Mr. Shazwan. Please, Mr. Shazwan, can you tell us more about the modification that your group have?
Hello, Assalamualaikum warahmatullahi wabarakatuh. Good morning to our boss and my team. So today I will explain about the shape. So the first is this old cross-sectional shape that is hexagon hollow shape. So we invent the new shape that is the new cross-sectional area. Why we choose this? Because the outer is the circular. When the outer is circular, the deformation will, when torque applied to our shaft, the spark plug toolkit, the shear strength will uniformly transfer. So that way the shaft will do not deform to the other shape into the other shape easily. So that will remain the plane of the shaft So that is one of reason, but we can prove our shape with the calculation. So this is our result. So you can see when we comparison side by side with hexagon hollow shape that is new old one and the circle with socket at the cross section with a new one, we know the shear size we can decrease the shear strength about 37%. So the angle of twist also we can decrease about 34%, and so the max torque of the new shape will increase about 58% percentage. That is for our investigation on my team. So it show the circle with socket head cut off cross sectional is better than hexagon hollow cross sectional when transfer the top. After that, we want to add in a piece of rubber into the spark plug toolkit. Why we want to add in a piece of rubber? We know the rubber will have higher coefficient of friction, so that will be the force, the frictional force will be 0 or less. So that will increase the efficiency of the torque transfer from toolkit into the spark plug. So that's all for me. Thank you.
Thank you, Mr. Shazwan, for the explanation. In fact, your project is very good. Well, this is good and interesting, especially since you took into your account the safety part by adding piece of rubber. In fact, it's safer and more effective at the same time, especially because the coefficient of friction that rubber has, especially since you covered a large number of problems and were applied to find effective solution to them. We are here in Marsh Holding Company. Will be very happy to have your project in our company. I would like to thank you for your efforts in trying to solve problems and providing suggestions based on effective calculations and theories. Thank you very much.